Solving exponential equations and inequalities. To solve exponential equations, you first need to get both sides of the equation to have the same base. And then when they have the same base, you just take the two exponents and equal them to each other. So for example 1, we have 2 to the x power is equivalent to 8 to the third power. They don't have the same base. The base is the big number. So think about it. How can 8 turn into a base 2 number? Well, 8 happens to be 2 to the third power. So, since 8 is 2 to the third power, we still have to raise it to the third power again because that was the initial power in the beginning. So, I would have now 2 to the x power is equivalent to 2 to the power of 9. Because if you have 3 to the power of 3 again, the two powers will multiply. That's the laws of exponents we talked about in the past. And now that both bases are the same, I will just simply take the exponents, which are x and 9, and equal them to each other. And look at that, I'm already done. On this next one, it says 8 to the power of 2x minus 1 is equivalent to 1 over 16 to the power of 6x. So, 8 and 16 share a common base of 2. We already established that 2 to the third power is 8. So again, the original power is still there. However, when you have 1 over another number, that means that the power is negative. So first ask yourself, 2 to what positive power is 16? And that would be 4. So that means 2 to the negative 4 power is 16. 1 over 16, sorry. So again, when a 1 is on top, that means you have a negative power. So remember what it is in positive terms and then just make it negative. So now both bases are the same. First, let's multiply my powers, because that's the rule. So it's 3 times 2x minus 1. So that'll be 2 to the power of 6x minus 3. You multiply 3 with both 2x and 1. And then on the right hand side is negative 4 times 6x, so that's a negative 24x. Now that the bases are the same, I can just take the powers and equal them to each other. So 6x minus 3 is equal to negative 24x. So now it's a linear problem, which means get x to one side, only x. So I would subtract 6x from both sides, which would leave me with a negative 3 is equal to a negative 30x. And then divide both sides by negative 30. To get x by itself. And when I do that, I would have a positive 1 over 10 is equal to x. Now we're going to solve inequalities. Inequalities, you do the same process as we did for equations. I first need to establish the same base. So we've dealt with these numbers already. So we know 16 is 2 to the power of 4. Sorry, that's a 4. And 8 is 2 to the power of 3. The 16 had an existing power, so let's rewrite it. And the symbol is less than. Now let's multiply the two powers. So I would have 2 to the power of 8x minus 12 is less than 2 to the power of 3. Now that my bases are the same, I can get rid of them. So I'm left with 8x minus 12 is less than 3. So now I will solve my inequality. Things you got to remember are the inequality rules. If you ever multiply or divide by negative, remember to change the direction of your inequality sign. Let's see if that happens. So there's only one x in this problem, so I need to move the negative 12 by adding it to 3 to get 15. And then divide both sides by 8, which is not a negative number, so my sign does not need to change. So that would mean x is less than 15 over 8. Let's keep it a fraction in those terms, please. Also in this lesson, we're going to talk about how to write exponential equations. The basic format is y equals a times b to the power of x. A is your initial or your starting value, aka your y-intercept. All right, so let's keep that in mind. It says Han starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. So the initial, or the A, value for this particular function is 7,500 bacteria. It then tells us after 4 hours there is 23,000 cells. So y is going to be the 23,000. And then x is going to be our time, which is 4 hours. So as you notice, we have a replacement for every part except for b. So we got to find b, or the value of b. So let's write out the original equation. Again, y equals a b to the x, and replace everything that is replaceable. So that is 23,000 here. A is 7,500. And then B stays B. And then X is 4. All right. So now I'm going to first divide both sides by 7,500. So that means B will be by itself, but to the 4th power. And then we need to calculate that using our calculator. So 23,000 divided by 7,500 is about 3.07. So now we're going to need a scientific calculator in order to find the 4th root of that number. So let's see. Okay, there we go. Let me see how I can use this one. Otherwise, I might have to get my graphing calculator. I don't recall how to use this one right now. I'm sorry. Let me get my graphic calculator. I'll be right back. Alrighty. So let me figure out what that was as a fraction real quick, because I'd rather use the fraction version than not. So So it's 46 over 15. I now need to take the second zoom, no. Second, or alpha zoom. Ah, sorry, y'all. Alpha zoom, nope. There we go. 6. All right, good. So recap. How did I get that? It was alpha window. Sorry. And then option 6. So I need the fourth root of 46. Sorry, y'all. I'm pushing the wrong buttons. Fourth root of alpha y equals 1 of 46 over 15. Now hit enter. And that's about 1.32. And does it have a fractional version? No. All right, so we got to use it as it is. So again, to get b by itself, I had to take the fourth root. And then I got 1.32. So now the equation would be y is equal to 7,500 times 1.32 to the power of x. For B, it says how many bacteria cells will there be after 12 hours? So using that equation we just wrote, we're going to replace x with 12 and use our calculator to figure out the result. So 7,500 parentheses 1.32 to the power of 12. So about 20,000, sorry, 209,869.07. 2,000 and 9,000, right? 209,000, yeah. 869.07 cells. And the last thing we're going to learn about is compound interest. This is the formula to calculate compound interest. A is your amount in the account. P, the principal or your initial investment. R is your rate as a decimal. So they usually give it to you as a percent. You must turn it into a decimal first. N is the number of compounding periods each year. So how many times is money added to the account in that year? And then T is how many years you're trying to look after. So an investment account pays 4.2% annual interest compounded monthly. So that means each month of that year, money is added to the account. So that means N would be 12 because compounded monthly, there's 12 months in a year. So there's 12 times in that year that money is being added. So compounded monthly, that means N is 12. 4.2%, that's R, but as a percent, so as a decimal, it's 0.042. You take the decimal place and move it to the left 2 times. And then it says 2,500 is invested in this account, so that's your principal. what will be the balance after 15 years? So this is T. So A is equal to my initial, which is 2,500, times 1 plus my rate as a decimal, so 0.042 over n, which was 12, to the power of 12 times 15, because t is 15. So now we need a scientific or graphing calculator. So 2,500 parentheses 1 plus alpha y equals 1.042 over 12. Get out of the fraction, then close your parentheses, raise it to the power of 12 times 15. Then we can hit enter. So this account will have about 46.88 and 87 cents. 46.88 and 87 cents. It's in dollars. So hundreds place is how we should round. All right. So this concludes the lesson. Please work on these problems on your own. And good luck.